Probability. 2.1 Sample Space. This is the video for Week 2, Probability, of the 8-week Statistics course. Probability is used in business, math, and science. Example of probability in business. Consider a randomly selected managerial person in a company. What is the probability it is a woman? If it is too low, it can be a case for a lawsuit. Another example. How much do you have to pay for your car insurance? All insurance/investment payoffs and charges are calculated with the help of probabilities. One of the most powerful and widely used methods in applied mathematics is Monte Carlo simulation. Let me explain how it works. Let's say we need to find the area of a shape inside a square of area 1. We generate 1,000,000 of random points in this square and count the number of points found inside a shape. Let's say this number is n. Then the area of the shape is n over million. An example of using probabilities in quantum mechanics is Feynman pass integrals. As opposed to classical mechanics, the material point moves from point 1 to point 2 not through a single deterministic trajectory, but through all possible trajectories. However, the probabilities for each trajectory are different. As a result, the problems of quantum mechanics can be considered at the problem of probability calculations. Today we will talk about 4 subtopics of probability: sample space, Venn diagrams and addition rules, conditional probability and independence, multiplication rule. The first subtopic is sample space. It is based on the notions of a selection. We will talk about selection as about some kind of an experiment. It is the processes that produces outcomes. The outcome is one selection out of some number of possible options. For example, testing new pharmaceutical drugs on a sample of patients and measuring the patient's improvement. Recording the stock price daily. Picking a card from a deck. Rolling a dice. Interviewing 20 randomly selected consumers and asking them which brand of appliance they prefer. And so on. Each experiment or observation has a set of all possible outcomes. For example, selecting a card from a 52-card deck has 52 outcomes. A set of more than one outcome is not an outcome. It is an event. Event is any subset of the sample space, including the entire space, sure event, an empty subset, impossible event. For example, the event red ace is selected is shown as the blue rectangle. Another example, the sum on 2 dices is greater than 9, is a set of 6 gray cells. Each outcome has some probability of happening. If the number of the outcomes is finite and all of them are equal probable, the probability of any one of them is equal to 1 over n, where n is the total number of outcomes. The probability of an event is defined as the sum of probabilities for all its outcomes. So, in case of finite equal probable outcomes, to find the probability of the event, we can count the number of outcomes in the event and divide this number by the total number of outcomes in the sample space. Often the outcomes are not equal probable. In these cases, we can repeat the experiment many times and count how many times the event has happened. The probability is this number over the total number of the experiments. It is difficult to implement such way of the probability assignment. The axiomatic method of defining the probability of an event is to assign the non-negative numbers to each outcome so that the sum of all these numbers for entire sample space is 1. The non-mathematical method of probability assignment is to ask an expert. For example, do we have any chances to receive the shipment? Sure, I think it is 50-50. Referring to the first, classical method, we see that the probability can be treated as an area. Each outcome is a small square or rectangle, and an event is a shape made of these squares or rectangles. Sometimes, we can replace a sample space so that each event in the old space is a union of the new outcomes. For example, we can replace none equal big rectangles as a union of small equal rectangles. After that we can use the classical definition of probability again. So, probability is similar to area. For that reason, it is convenient to use Venn diagrams as events in the sample spaces. We will do it in the next subtopic.